Greetings, you're watching Oliver Medok Peterson, AU 617-191 of Group 15 with the third iteration of the HotSIF project. And in this video, I'm going to be showing and explaining the architecture and implementation of HotSIF that allows the use of the various SIF games. And a key goal with this whole refactoring and strategy-based implementation that we have used was to allow ourselves to delegate the responsibilities from our game implementation class to new delegate objects that will allow us to use this strategy pattern to handle the variations of each game. And to explain this, I'm going to take a basis in the 3-1-2 process. And our third principle from the strategy-based pattern was to consider what should be variable in our design. And if we look at the requirements for beta SIF and gamma SIF, we see that there's a difference in how the winner is implemented, the world aging algorithm, as well as the unit actions for the settler and archer. And if we look into our class GameImplementation.java, we see that this means our methods getWinner, end of round, and perform unit action at methods all have become variability points that we need to be able to change using our strategy-based interface. And to implement the code that will handle these variations, I followed the first principle of the 3-1-2 process, which was to program to an interface, not an implementation. And therefore, for each of the three strategy types, I introduced a new interface to handle these variations, those being action strategy, age strategy, and winner strategy. And to show how this relates in practice, I created this little UML diagram excerpt to show how these methods act with one another. And a key point when making these classes was to allow each variation to use the same methods for instantiation and method calls, those being the getWinner, end of round, and perform unit action at method, but only change the implementation of these methods, which were handled each by an age strategy interface, the action strategy interface, and the winner strategy interface. And essentially, what we're doing by changing the implementation of these methods by handling them in delegate objects, those being each of the strategies, we are loosening the coupling of each class from our game implementation class, as well as reducing the bloating of our game implementation class. And instead, we delegate these responsibilities to the winner strategy objects that we add to our game implementation when we create the new game implementation with each of the three strategies as our parameters. To select which element of the variable behavior that we want to utilize, we change the object composition of our new game implementation line in order to compose the behavior of each implementation. And to show how we change the strategies the object should utilize, I will go into my test-alphasif.java file, in which we have a known winner strategy and aging strategy, but no action strategy. So the way we create a new AlphaSif game would be to create a new game implementation where the winner strategy would be a new AlphaSif winner strategy object, and the aging strategy would be a new AlphaSif age strategy object. And since AlphaSif doesn't have any unit actions implemented, we don't pass a action strategy object to our new master objects. And this line of code right here decides which kind of game rule has to be applied. And this line of code selects which element of the variable behavior we want to utilize. And by changing the composition of our game implementation, we change the rules of the game to suit whether we want an alpha-sieve game, a beta-sieve game, or a gamma-sieve game. And by changing the parameters, so for example, we could change this to a beta-sieve winner strategy and a beta-sieve winner strategy, we have now created a new game implementation with these new rules. And in doing this, we have essentially exploited the key advantage of this strategy pattern-based approach, in that we only define which rules we want to use the second we create the new game implementation. And when we actually program to these interfaces and want to create a new strategy for us to use, we essentially just create a new class that overrides the interface with the strategy that we want to override. This has been Oliver Medok Petersen, AU 617-191 of Group 15, explaining the architecture of the HotSIF project using the strategy pattern-based approach. That's about it. Thanks for watching.